All right, so I'm going to go ahead and get through the rest of Unit 5 with this section. I'm sorry, I'm just a little bit tired right now, but yeah, I totally screwed up the previous question. I think in the video I accidentally why am I going into shape? I accidentally wrote that as 4/5. Should have been 4/3. So with it being 4/3, it actually turned out to be a much more complicated route. So the answer was actually 25/3. So I'm really sorry about that. I caught that afterwards and I was like, I don't know. Let me double check my fractions because I'm just not even thinking straight at the moment. But yeah. So that's how you do number 90. So let's go ahead and do the next one, number 91. What is the absolute maximum value of y equals 32 square root of x minus x squared? So this doesn't look much fun either, but that's okay. We'll test these out. So we have y prime is equal to, this is like saying 32x to the 1/2 power, so that's 16x to the negative 1/2 minus 2x. And we got to somehow set this equal to 0. So the first thing I'm going to do is I'm going to go ahead and I don't want to deal with negative exponents, so that's like saying 16 over the square root of x. And then if I subtract 2x from that, I think it'll just make sense to just subtract it from 2x square root of x to have that common denominator. And then now I can go ahead and set that equal to 0. So I can combine that, and then I'll have 16 minus 2x square root of x over the square root of x is equal to 0. And so I know there's no point in setting the denominator equal to 0 because 0 is just kind of like the beginning of our domain if you really think about it. But anyways, like I said, most of the time you're going to set your numerator equal to 0. So I'm going to have 16 minus 2x square root of x is equal to 0. I would rather think of this instead as 16 minus, because if you have, and I'll do this, I'll kind of do this on the side over here. If I have x times the square root of x, that's like saying x times x to the 1/2, which is like saying x to the 3/2 power. So I'll consider that. So that'll say like, so if I move this to the other side, I'll have 16 is equal to 2x to the 3/2 power. So then that'll be 8 is equal to x to the 3/2 power. And then to get rid of that 3/2 power, I'm going to raise both sides to the power of the reciprocal, so to the 2/3 power. So those will cancel. And then 8 to the 2/3 power. So I'm going to start with my denominator. So the cube root of 8 is 2. And then the 2 squared would be 4. So x equals 4. There we go. So we got our critical value. Okay, x equals 4. So if I want to know the absolute maximum, I'm going to make my list over here of my x and y values. This is not going to be fun. All right, so this is going to be 0, 4, and 9. So if I plugged in 0, that's at least easy enough. It'll just be 0 when I plug it into the original function. If I plug in 4, that'll be 32 times the square root of 4 is 2 minus 4 squared. So that's equal to, let's see, 64 minus 16, which is, what is that? That's equal to 48. And then if I plugged in 9, that'll be 32 times 3 minus 9 squared is 81. That's 96 minus 81, which is 15. So it's not 15, and it'll be 48. So that'll be the absolute maximum. Out of these three values, the absolute maximum was 48. All right, that wasn't as bad as the other one. At least I didn't have to deal with fractions. All right, so the function f is given by f of x is equal to x cubed minus 2x squared. On what intervals is f of x concave down? Okay, so for concavity, I'm going to figure out when the second derivative is equal to 0. So f prime is equal to 3x squared minus, man, I just should not be doing, okay, minus 4x. F double prime of x is equal to 6x minus 4. When is that equal to 0? So I know I have my inflection point, not critical point. My inflection point is going to be x equals 2/3 if I added 4 and divided by 6. So now I'm going to test 2/3. I'm going to test a test value on the left and a value on the right. So if I plug in 0 into 6x minus 4, because this is my... I don't want a shape. Because I'm going to plug it into my second derivative to test to see concavity. If I plug in 0, I'll get a negative number. If I plug in 1, and 6 times 1 minus 4 is a positive number. So that means that I'm concave down and concave up right here. So I'm concave down from negative infinity to 2/3. All right, 93. Let f of x be a differentiable function. The graph of f prime, the derivative of f, is shown above. On what intervals for x values between -6 and +6 is f of x... Why is there a question mark there? Is f of x concave down? Okay, so let's see. If it's concave down, I need to figure out when f double prime of x is less than 0. So what is that in terms of f of x? So I need to know if f of x is pretty much decreasing, right? Because the decreasing will pretty much tell me the next derivative after this one. So that'll pretty much tell me if f prime of x is decreasing, then that means that f double prime of x is less than 0. So where is this decreasing? Look at my highlighter. It's decreasing from here to there pretty much. Then it starts to increase. Why does it do that? So from there to there. And then it decreases from here to here. So the answer is from -6 to -2 and from 4 to 6. D. All right, so then for number 94, if f of x is equal to x cubed minus 6x squared plus 4, at what x value does the graph of f have a point of inflection? So point of inflection, that's just the second derivative equal to 0. So the next derivative would be 3x squared minus 12x. And then the second derivative will be 6x minus 12 equal to 0. So at x equals 2. Finally, an easy one. All right, let f of x be a differentiable function. If f prime of a equals 0, okay, so that means that a is a critical point, right? If you get the derivative equal to 0, that x value is a critical point. Then which of the following values of f double prime of a guarantees that x equals a is a relative maximum of f of x using the second derivative test? Okay, so if I can tell a maximum using the second derivative test. So in other words, if I did the second derivative and then I plugged in a, because it kind of looks like what all of them are asking for, then I'll know if I have a relative maximum if this is a negative number, right? Because if f double prime, that tells you concavity, and if the f double prime is negative, that tells you it's concave down, which means you'll have a relative maximum right there at that point. So that has to mean, which is a. Nice. Okay, so that's the only one that gives you a negative value for your second derivative test. Okay, for number 96, if y is a function such that y prime is less than 0 and y double prime is greater than 0 for all x, which of the following could be the graph of y equals f of x? Okay, so y prime is greater than 0, less than 0, so that means that the slopes, because remember, first derivative is slopes, and if the slopes are less than 0, then that means it's decreasing. Y double prime is greater than 0. That tells me it's concave up. That does not... concave cup? Concave up. So decreasing, concave up. That's increasing. Here's a decreasing, and it's concave up. So far B looks like the best. That's decreasing. That's increasing concave up. So yeah, I'll go with B. Okay. I don't know if these videos are even making any sense, but whatever. For number 97, the graph of f prime, the derivative of f, is shown in the figure above. Which of the following could be the graph of f? Oh, so now we have to go from the derivative to the original function. So let me think about what the derivative even gives us. So the derivative, what that does is that tells me if f is increasing or decreasing. Right? I know it's increasing if f prime is above the x-axis. and decreasing if it's below. And then I also know like when if f prime of x is equal to 0, then those are critical points. So that means I'm going to have some kind of relative maximum or minimum there, especially if it changes signs. So that's kind of good enough. Like I know that at those x values I should have a relative min and max. So far A kind of looks like that. So I have a relative min and max at those x values. And then if you think about it from like these two regions, that's when f of x is below the x-axis. So I know that at those two regions, right, that's telling us that the original function is decreasing if f prime is below the x-axis. And then for this region above the x-axis, that's telling me that f is increasing. So honestly, that looks like A, right? Yeah, because if I look at my yellow highlighted region, it's decreasing in that. And then for the part in between those two, it's increasing, right? So that's pretty much telling me that. I do have I'm going to go with A. For those, I usually have to like sit down and look at it a little bit more longer. Okay, the sum of the height and radius of a right circular cylinder is 12 inches. What is the maximum optimization? That was everyone's favorite chapter. Okay, so the volume of a cylinder is V equals pi r squared h. So I need to find the maximum volume of the cylinder. So I need to know when this is at a maximum. And how do you determine the max or min of anything? You take the derivative. So I can do V prime. See, but then over here I have like two different variables, right? Let me read the question again. The sum of the height and okay, so they gave us something over here for remember the phrase secondary equation? So I know if the sum of the height and radius is 12, so r plus h equals 12. They want to know what is the maximum volume of the cylinder. I think it'd be easier to substitute something in for h because I don't want to FOIL anything. So I'll get h by itself here. So I'll have h is equal to 12 minus r, which now I can plug this in for h. So that'll be pi r squared times 12 minus r. So now I have everything in terms of v in terms of one variable. So I shouldn't say that's v prime. This is just v. Sorry. So v is equal to that, which v is equal to pi r 12 pi r squared minus pi r cubed. That's ugly. Hold on. Pi r cubed. So now to find the maximum of v, I set the first derivative equal to 0. So then I'll bring that. So that'll be 24 pi r minus 3 pi r squared. I gotta set this equal to 0, so I'm going to factor this. So I can take out a 3 pi r, and then I'm left with 8 minus r is equal to 0. So then r can either equal 0 or r can equal 8. That doesn't make any sense. How are you going to have a radius of 0? So I'm going to just test 8. And I guess technically what I should be doing is I should be like, either doing the second derivative test and plugging that in to see if it's a relative max or min, or do like plug in 8 and see if it's increasing, decreasing on either side of that to verify. But honestly, if that's my only critical value, this is multiple choice. I'm going to just go with the flow and just kind of assume that that's going to be a maximum value. So if I just plug in r into my original volume, then that'll be v is equal to pi times 8 squared, and then h, well, I know that h is 12 minus radius, so that'll be 4 in this case. So if the radius is 8, then the height is 4. So then that'll be 64 pi times 4, and then 64 times 4 is 16 plus 240 is 256. So should be D. I'm going to go with that. All right, so the curve xy plus y squared is equal to 5x minus 11 has a vertical tangent at x equals... This was chapter 5? I guess so. I thought this was like a unit 3 problem with implicit. Okay, well, great. I'll do implicit differentiation. This is, and with product rule, how beautiful. So I'm going to do the implicit differentiation, get dy dx. Because remember, with the vertical tangent, that's when you have the denominator equal to 0, or any kind of vertical like asymptote or whatever. But so the denominator of the derivative, it has to be equal to 0. So let me find dy dx first. So first times the derivative of the second plus the second times the derivative of the first plus 2y times dy dx, because I took the derivative of a y. That's all equal to 5. So I'm going to move this to the other side, and then I'll factor out a dy dx. I'll try to do this all in the same step. So dy over dx, when I factor that out, I'm left with an x plus 2y. And then this y, well, basically y, I'm just moving it to the other side, so that'll be equal to 5 minus y. So then dy over dx is equal to 5 minus y over x plus 2y. This was the thing that none of you got on that chapter 3 test. Now I got to set my denominator equal to 0. But there's a problem, because when I do that, I have x plus 2y is equal to 0, and it's going to be like, how am I going to solve for that when I have two unknown variables? So ultimately, we want to know at what x value is this all happening at. So what I'm going to do is I'm going to write everything in terms of x. So I'm going to subtract x from both sides, and then I'm going to have 2y is equal to negative x, which essentially means that y is equal to negative 1/2 x. So the thing is, what you can do from here is you're like, I don't know. If I need to figure out what x is, right? It'd be nice if I had a secondary equation to kind of like double check that, because this function right here, or this equation right there, would pretty much give me the vertical tangent. So I do have a secondary equation. I have the original one. So I'm going to plug in negative 1/2 x wherever I see a y. And so, yeah, I'll do that. So I'm going to have x times negative 1/2 x plus, and then when I plug in that into negative 1/2 x, all of that squared is equal to 5x minus 11. Okay, so this will pretty much be negative 1/2 x squared plus 1/4 x squared equals to 5x minus 11. If I combine those two, negative 1/2 and positive 1/4, that's like saying negative 2/4 plus 1/4. That's negative 1/4. So this will be negative 1/4 x squared is equal to 5x minus 11. So to get, I don't want to deal with fractions, so I'll just multiply everything by negative 4. Multiply all of this by negative 4. So then that'll cancel out with that. So I have x squared is equal to negative 20x plus 44. So I got to figure out what x value this occurs at. So I'll move these to the other side. So it'll be x squared plus 20x minus 44 is equal to 0. And handy dandy factoring. I'm sure this factors out nicely. It has to. So then if I have negative two numbers that multiply to give me negative 44, that'll give me the middle term positive 20. So it'll probably be some combination of 22 and 2, because 22 times 2 is 44. But then I need to get the positive 20, so it'll be plus 22 and minus 2. So plus 22 minus 2. And then that means that x is equal to negative 22 or x is equal to 2. So 22 is not my option, or is not an option, so it'll be c equals 2. Not c equals 2, x equals 2. All right, so that was not fun. Again, I think as we're doing these multiple choice practice problems and as you go through the AP test, some of these you probably can do. But if you sit down and you realize that you're going to take too long on a problem, you should probably skip it and get back to it if you have time. Get through all the easy questions first that you know will take you no time. And then, yeah. So for number 100, what is the... Wow, we're on number 100. So what is the x-coordinate of all points on the curve that it had on that has a horizontal... Okay, so horizontal tangent. So remember how with vertical tangent, that's when the denominator equals 0? Horizontal tangent is when the numerator would be equal to 0 of your implicit. So if I take the derivative of that, that'll be 3x squared plus 2y dy over dx is equal to 27. Oh, nice. This looks like it's going to be much easier. So I'll have 2y dy over dx is equal to 27 minus 3x squared. And then dy over dx, if I divide both sides by 2y, I'll have 27 minus 3x squared over 2y. Perfect. So for the horizontal tangent, I'm going to set my numerator equal to 0. So then that'll be 27 minus 3x squared equals 0. 27 equals 3x squared. 9 equals x squared. X equals plus or minus 3. Boom. All right. That was tough. That whole chapter 5 section, well, not the whole chapter 5 section, but I think a few questions really got me. I mean, yeah. So I'm going to check these answers, and if I make any mistakes, I'll let you know. But yeah, let's just end it there. I'll work on making the Unit 6 videos and not wait too long to do them so that I can get these out to you as soon as possible so you can get the adequate amount of practice. It's all about practicing and getting yourselves ready for the AP exam. So I'll let you guys go. Take care. Have fun. Bye-bye.